Today's lesson 9.4 is finding the range, quartiles, and interquartile range of a data set. First thing we need to do is write down these vocabulary words. Measure of variation. A measure of variation is a measure that describes the distribution of a data set. A simple measure of variation is to find its range. The range of a data set is the difference between the greatest value and the least value. Take a minute, fill that in, and come on back. Okay, example 1, page 414. How do I find the range of a data set? Basically, to find the range of the data set, once again, you have to put them in order, either from least to greatest or greatest to least, either way. You would then subtract the lowest number in your range of data from the highest number. So in this case, you had 18.5, which is the highest, minus 5, which is the lowest, and that will give you 13.5. And that is the greatest distance between the two lengths, is 13.5. So what you need to do, that was pretty easy, it's pretty much a review. Please do the on your own number 1 on page 414 and come back for the answer. On the on your own number 1, the question is find and interpret the range of their ages. So in example 1, you looked at the list of ages, subtracted the least from the greatest, came up with 41, and then your interpretation of that data is the ages of the people in line vary by no more than 41 years. The biggest part about finding range, I know you know how to do that, but it's interpreting that. So what that is telling you is from the least to the greatest, just like here in your example, that is the greatest distance. So they cannot vary by any more than that because they all fit within that range. Okay, so moving on to key ideas, same page. Here is something that's a little tougher than range. So let's go through this, and then you need to write definitions into your notebook. First of all, the quartiles of a data set divide the data into 4 equal parts. Recall that the median, right here between the whole thing, is the second quartile. That divides the data set into 2 halves. Once you divide it in half, you take the first half and divide that in half, and that is the median of the lower half, which is called the first quartile. Then, after you've split it in half, if you go to the right of the median, the upper half, figure out the range there, or the median there, sorry, and that is the third quartile. Now, interquartile range seems complicated, but we'll go through examples. The difference between the third quartile and the first quartile is called the interquartile range. The IQR represents the range of the middle half of the data and is another measure of variation. So here's what they've done. To get the IQR, you take quadrant 3, right there, because that's a higher number, minus quadrant 1, which is a lower number, and you will get the interquartile range, which is 10. Okay, if you would please put that into your notes, all this information, and come back when you're done. Okay, to put this in perspective, think about the activities that went with 9.4. They had you take a strip of data and you folded it into 4 sections. When you folded it in half, you were able to get the median of all the data. Then when you folded the first part, you received the median of quartile 1. When you folded it to the right, you received the information or the median for quartile 3. Now, all this tells you, if you're looking right here on the screen, what this tells you, okay, is your actual middle 50% of the data. You go from here to here, first to third, and you have your middle 50% of your data. The rest of the data is the other 50%, but the middle 50% of the data is between the range between the lower half and the upper half. All right, so let's look at example 2 on page 415. Now, what they did is do a dot plot in the book. It shows the top speeds of 12 sports cars. Find and interpret the interquartile range of the data. So the first thing they had to do was take all the information and list it out, excuse me, so you could find the range of the data. All right? All your data, least to greatest, is listed out in a list. Then what they did, right here, then what they did would be is if you took that strip that you did before, folded it in half, you would find the range. In this case, your range, sorry, not your range, your median is right in the middle. So just like you would normally figure out a median, you've got 1, 2, 3, 4, 5, 6 on this side, 1, 2, 3, 4, 5, 6 on this side. You need to figure out what is in the middle. One of the ways to do that is add those two numbers and divide by 2, and you have the average. So right here is your middle. All right? The biggest key in this, the biggest key that I can give you right here, even though you have a dot plot, and that's what they have in the book, or any other kind of chart, you will definitely make less mistakes if you rewrite the values of data in order. So keep that in mind. I know you guys like to do it in your head, but if you do this, write it out, you'll make a lot less mistakes. So then what they did was they found the interquartile range for the first half, for the lower numbers. Quartile 3, they figured out the median there. Okay, so you have 235, you have 255. You take quartile 3, just like your notes, minus quartile 1, and it gives you 20. This means that the middle half of the speeds vary no more than 20 miles per hour. Okay, so what that's saying is the numbers from here to here, the middle numbers, vary no more than 20 miles per hour. All right? It's still confusing, so we're going to watch a movie, a video, and then we will move on from there.
Welcome to My Secret Math Tutor. In this example, we're going to find the interquartile range. Now, what the interquartile range is it's basically the range of the middle 50% of all of our data. All right? So the way we're going to work this is first we're going to organize all of our data from lowest to highest. Then we're going to find the median of the upper half and the median of the lower half. And then we're going to subtract the two in order to find that range. Okay, so let's see how this process works out. So first I'm going to take all of this data and just write it out from lowest to highest. This will just allow me to get a better visual sense of where the median of the upper half and lower half fall. There we go. There's all of our data. Now you'll notice that I have an odd number of data points. This actually makes a little bit of a difference. It means that when I go to find the median of the upper half and the median of the lower half, I first have to find the median of the entire set of data. So imagine working from both ends to find that middle point. And it looks like it's 10. Now since we have an odd number of data points here, when I go to find the median of the lower half and the upper half, I'm not going to include the 10. There we go. So now let's find the median of this lower half and the median of the upper half. Let's say I got 1, 2, 3, 4, 5, 6, 7 values here. The median would be the 7. Let's see, for the upper half, looks like the median would be the 15. Now some books actually give these names. They call them Q1 and Q3. That's okay, because what we're basically going to do is now take Q3 and subtract Q1. So 15 minus the 7. That will give us an answer of 8, and that 8 happens to be our interquartile range. Now this example works out slightly different if you have an even number of data points. Basically you would find the median and then find your lower median and upper median and subtract the two from there. If you'd like to see some more videos, please visit mysecretmathtutor.com.
Here is an extra example I'd like you to work on. Read through. There's a couple things I want you to do is list the numbers in order to find the median, which is the quartile, sorry, that's wrong, quartile 2. And then I want you to find the median of each quartile, numbers 1 and 3, and then answer the problem. Come back when you're done. All right, here's the answer to extra example number 2. Quartile 2, dividing these numbers in half, was 546. That's your median. Okay? Quartile 1 is the median between here and here, the lower half. That was 489. Quartile 3 was the median between the upper half of the numbers, and it comes to 667. So just like your formula tells you in your notes, you subtract quartile 1 from quartile 3. So it's Q3 minus Q1, and you get 178. So what does that tell you? The average amount of pages within that 50% of the data, the average amount of pages vary by no more than 178. So the average number of pages vary no more than 178. That's what you've done by figuring this out. You've been able to discover that. All right, I'm going to pause here, and you can watch part 2.